So welcome. I was invited today to give a talk. I thought, why would anyone want to listen to me for half an hour? So what I'm rather going to do is show you lots of videos of things burning. And entitled it, Are Flammable Cities a Vision of 2035? Why? It's roughly 10 years' time, and it's roughly what do we need to worry about in the near future? Because today is a very exciting day for fire engineering in the industry. Moving forward, testing is critical in our industry, but we also see how much there is still to do. So this is the first step. So first, for those of you who aren't from a necessarily fire engineering background, a crash course in fire dynamics. So here's a room, you fall asleep, cigarette, why are you smoking? Anyway, you ignite the couch, hot smoke starts rising up, a hot layer builds up at the roof. Now, this is where testing comes in for reaction to fire. Does something ignite, and how does the fire spread across the surface? You have a hot layer that starts building up at the roof level. It is now radiating down on the floor. Once the radiation from the hot layer is sufficient, you have what's called flashover. You transition from a localized fire to hot layer to all room involvement. It burns as fast as it can go. You have flames emerging from openings as it comes looking for oxygen, basically. So wherever there's air, combustion occurs. So you now see flames starting emerging out of any hole you have available. Testing is in the background to this when we try to make sure that doesn't happen, because that's not what we want. So if we have a look at a standard time temperature curve to map that out, so this is temperature on this axis, time, we have some ignition event. And at the beginning, to prevent that, you always have ignition sources, whether it's the coffee machine or an electrical fault, there's always an ignition source. You can never cut that out entirely. You initially want your reaction to fire. Can it ignite? How easily does it ignite? How does it spread? So that's what you need to test for. Then you also have detectors. How does the detector activate? How does it respond? Is it smoke, heat detector, etc.? Then you move through to testing of smoke extraction and sprinkler units. So that is then some other materials engineering systems. Post-flashover, we have fire resistance. Is our structure staying sound? So even if all hell's broken loose, there's been fire spread, you have flashover, at least the building doesn't collapse. So there what we do is we fitted a standard fire curve to this overall incident. It tells us nothing from ignition to, well, hell, I'm dying here from smoke inhalation and I actually collapsed dead there. This tells me nothing. 30 minutes tells me nothing about me collapsing on the floor from smoke here. This tells me early ignition and development. And then beyond that, you will see a fire resistance test soon, which quantifies a resistance to a specific curve. And that's where the different tests and different approaches come in. So we're going to start talking about where to next. So firstly, Thomas Edison said, fooling around with alternating currents is just a waste of time. No one will ever use it, ever. It's too dangerous. It could kill a man as quick as a bolt of lightning. Direct current is safe. So according to one of the greatest engineers of all time, don't use alternating current. It could kill you. I think we've moved on slightly since then. We have emerging technologies. We can't ban them. We never banned alternating current. That would be ludicrous. If you went up to someone now and said, let's ban AC, they would say, you are nuts. But we have learned to make it safer. So, lithium-ion batteries. Here's some small pouch batteries. These go in drone type. That was done out there, not many long ago. That's a couple of small batteries. That is the sort of thermal runaway phenomenon you get. It's actually jet flames. It's producing toxic smoke, and the smoke can be can ignite and be explosive. So you get home, you've got like a little bike. You take it to your apartment on the 12th floor, you plug it in, it's charging, you had mucked around with the charger a day or two ago. Yes, you people are mean laughing at this poor guy. So you have an ignition source, toxic smoke, rapid flame spread. If it had been next to the Christmas tree, it'd be game over by now. The Christmas tree would already be a candle. And the poor guy is trying to escape. This is real time. This is not accelerated. We now have these things all over in our apartments or blocks in Stellenbosch. They're now little blue ones that are running all over the campus. And once in a while, someone will take it to their res room and plug it in. So, just in case though, if something does go wrong in your garage, at least you have a pressure relief vent, otherwise known as your garage door. And the pressure buildup, if ignites, can cause a deflagration. So do you have a vent to then release it so it doesn't cause structural damage? And so that's the sort of risks we are being facing. Literally, I was standing here earlier. If you saw me pass something to Brian Meacham and say, check this, I literally got an email while we were sitting in. Hey, I'm designing, there's a lithium-ion battery in a child's room. I'm like, oh hell. Follow email through. I was like, this is not good. So New York batteries, 200 fires. Then we put them in our material handling equipment. If you are, let's say one ignites and it spreads through 12, the loss is one thing. The insurance can pay for the loss, but you wipe out the food supply from a warehouse for Checkers, Pick n Pay, Spar, whoever. You may literally wipe out a food supply to a region if those are not protected. Then hydrogen. Hydrogen, it burns cleanly. H2 plus O2 gives you H2O. There's no carbon emissions from hydrogen combustion. That's why it's often liked. So we can put it in our car. We can power our cars. We get there. Imagine this in South Africa, filling up your own car. So we pump high pressure gas. There we go. We fill our cars. And South Korea says, hey, we want to create 6 hydrogen cities to use H2 in buildings and transport as part of daily life. So we will have in large quantities. We even get space-age planes and boats with it. I don't know when those arrive, but apparently that's part of it. So H2, for instance, it's colorless. It's not green hydrogen. It's just made from green sources. It's very light, incredibly wide flammability limits. The main thing is it's very easy to ignite, even compared to methane. High energy content. It's very light, though. So what? What happens if you have a flammable gas that builds up somewhere that's lighter than air? Well, that's what happens. So this was downtown Joburg, Greece Street blast. You had a pressure wave of about 6 times the speed of sound, 8 bar pressure. So what does this look like scientifically? You have a tunnel, the Kloof tunnel, or a parking garage, and your car leaks. And you have a flammable gas mixture, you have an ignition source, then you have what's a flammable gas mixture, it ignites, and then the flame front starts propagating. The flame front hits the side, start interacting with the side, it actually pulls in more gas and accelerates along the side. You get acceleration, you get acceleration. As it heats up, the air ahead of it actually gets faster and faster. So what happens is that as much as there's a flame front there, the air in front of it is being pressurized and it's accelerating. When it hits the speed of sound, there's an ignition on your face and you have a shockwave. You have something going faster than the speed of sound. So as I said, Joburg, probably 6 to 8, max 6 to 8, 2,000 meters a second, 8 bar pressures, boom. And that was somewhere between 75 and 200 kilograms of methane. That wasn't large quantities of methane you saw you needed to do that. So solar. What about solar? Well, Earth experiences enough solar radiance. I borrowed this from someone sitting in the audience. I stole his slides. That's what students are for. So we have massive capacity going in, massively growing industry. It has associated risks. It has... We can design for these things, but you do have ignition sources you never thought about. You do now have spread mechanisms where what happens if your firewall ran there and the flame jumps your firewall? Your firewall is now redundant. And you can violate the purpose of the act in terms of limiting flame and smoke spread. You can also then see, so this is some testing. Grunde Jonas and Jens Christensen and the likes have done some interesting work. So this is a tiny little wooden crib, yay big. And it's underneath a panel. There's some combustible backing and other combustible materials around. And so once it ignites, you have trapped the heat there and it can spread. Now this doesn't happen every day, but you do have an area where you can cause more rapid flame spread, and especially if your insulation material is combustible, you've got a big problem. So the insulation now is becoming a big issue. And this is where I said this is just the start. We need to see tests out that window soon with roofs, with panels on, with insulation, and you test a roof setup. Not, I've got a class this and a class that, and I chuck in some insulation from the lowest bidder. No, you test a system. So that is going to become critical in the future as we move forward, because you have large incidents like this in the US, you can have flame spread underneath the panels. There are ways to mitigate all these things. Even green, we like green facades, so we clad our buildings with plants. Then a drought, droughts never happen in this part of the world, hey. And the bylaws prohibit you legally from watering your plants. That turns into fuel, and this is Wojciech Wierenski and his team. They've really annoyed a lot of people. Apparently the industry hate them for showing this work, but you can get flame spread rapidly up plant base, and it's outside of the code. You get code compliant, because the code never thought your building would be covered in plants. But you then have the Act. The Act says flame spread must be limited. So your code compliant building may violate the Act by having a continuous path of greenery up the side of the building. And we've had incidents around the world. Middle East, there's been many, Grenfell Tower, combustible facades. This is a complex incident with many things that went wrong, but this type of facade material, which is one of the problems, is on buildings in this country. Joburg, Cape Town, Durban, I don't know which ones. The architects and the engineers who know, they have amnesia, they've forgotten, they do not want to know, because it may cost 50 million rand to retrofit one building if it was specified. So this is something we are going to have to deal with as an industry at some stage. I don't know how, but it is going to come up at some stage, the composite materials. And so that's where testing comes in. You look to the yonder corner, you will see a large-scale facade test. We can now get facade testing done. That is critical. And if you even think buildings are the only place where we need testing done, this emerged over the weekend in Leipzig. And a Ferris wheel. The Ferris wheel caught fire. This is quite phenomenal pictures. Must have been absolutely terrifying. And you would need to see what is the combustibility of your materials. I'm assuming there were plastic panels or something that ignited. What the ignition source, we hope to hear. But and boats. This is in Croatia in a boatyard. 22 expensive boats burnt out. So we have combustible materials popping up all over the show. And so we think, you know what? Concrete is safe. Concrete is never a problem. Until you get explosive spalling, where you go to high-strength concrete, let's say 60, 80, or 80, 100, 120 MPa concrete. It's highly dense, so what happens is when the steam builds up, it can't escape, so it blows. You create a steam pressure that can cause your non-combustible, very safe concrete to pop. And this is high-performance concrete that you may use in a tunnel or a high-rise building. So suddenly, even concrete may not be fire safe as we thought. So this is where our industry testing and all this converges, where we need to evaluate these different systems. So this is some sort of things to think about, as I said, a fire industry for 2035. Fire testing will be fundamental to promoting sustainability, hence there'll be a growing emphasis in the coming years. Major new challenges will be arising with green energy, growing populations, poverty, taller buildings, bigger warehouses, aging infrastructure, aging populations. Fire engineering will be core to addressing these. Test lab capacity in South Africa will need to at least double in the next 10 years. Plain and simple, if you have a look at those industries I just discussed, to keep up with the mines, with the cables, with the products, with all these sorts of things, the test capacity, we even had discussions earlier about firefighter garments. We need tests for garments against these sorts of things. So, and just as a note, with a university now producing students' local capacity, it would not surprise me as if we see the Cape becoming a center of excellence in it. When you've got multiple organizations, if you look at the in the US, northeast corner between Boston, DC, we've got Maryland, WPI, NFPA, SFP, the big organizations where they feed off each other. And you find a growing happening of an industry. And we have a base here to serve the African continent. If you look at the mineral exploitation, the mining, the transportation, etc., I think we have a fantastic opportunity to serve that industry. And before we do it, we've got a lot of stuff to burn. So thank you, ladies and gents. That was hopefully quick and cheerful, just to keep you awake. And if you don't know what fire engineering is just in closing, I'll read the definition. If you're new to the field, It's the science of protecting society by designing for a phenomenon that cannot be readily predicted, with risks that are ever-changing, using systems that the client will maintain, while applying codes which are sometimes unclear, in conjunction with professions who have no idea what you do, such that the people have no reason to suspect the extent of the ever-present risk.